So hi everyone, my name is Shivam Bohra. Welcome to the official channel of CodeChef. So if you want to learn and master data structures and algorithms, or if you want to do really good at competitive programming, then this is a one-stop destination for you. Now before we actually get started, here's a quick reminder for you to hit that subscribe button if you haven't already yet. So now let's move on to the next problem. So the problem statement says that given n numbers a1, a2 and so on till an in ascending order, find the count of a number x in this array, right? So basically we have some numbers given to us in ascending order. We simply have to find the count of this number x inside this array, right? So let's say I have 1, 2, 3, 3 and 4, 4, 4 in my array, and I want to find the frequency of 4 in this array, right? So we can easily see that 4 over here is present 3 times. Hence, the answer for this would be 3, right? Similarly, if I want to find the frequency of 3 in this array, then we have 2 3s over here. Hence, the frequency of 3 would be 2. So 2 would be the answer in this case. And if let's say I want to find the frequency of 5 over here, then there is no 5 in this array. Hence, the output would be 0 in this case, right? Now let's see the constraints for this. The size of this array n, it could be as big as 10 to the power 9. N over here could be as big as 10 to the power 9. So many of you might have thought that we can easily traverse through this array. We can easily traverse through this array and we can simply find the frequency of that particular number, right? By simply using a simple for loop. But the size of this array is 10 to the power 9. So if we even use a simple for loop, then it would work in big O of n time complexity, right? And big O of n over here means that 10 to the power 9 steps. Hence, big O of n approach over here would not be acceptable. So now let's move on to the approach. So here we have this array and the value of x is 3. So I want to find the count of this 3 inside this array. So firstly, I'll initialize a variable count to 0 and I'll start traversing this array from the very leftmost element. So I'll start traversing from here and I'll keep on traversing till I find a 3 inside this array, right? Or I find an x inside this array. So as soon as I found a 3 inside this array, I'll simply change the value of count from 0 to 1, right? And then I'll move on to the next element. This is again 3. So again, I'll change the value of count from 1 to 2, right? Now this is 4. So I can stop over here, right? Because the rest of the array elements would not be 3. They are going to be greater than 3, right? So the count in this case would be 2. Now the issue with this approach is that if let's say I want to find the frequency of 6, then in that case, I have to traverse the whole array, right? So the time complexity in this case would be big O of n. And in the previous slide, we can see that n could be as big as 10 to the power 9. Hence, big O of n approach would not work in this case, right? So I have to come up with a better approach. Now we can see that the maximum size of this array n could be 10 to the power 9, right? Hence, a log n algorithm would be good enough to solve this problem in time, right? So over here, we can see that the array is given in ascending order. Hence, we can perform binary search on it, which works in log n time complexity, right? And if we are able to solve this problem using binary search, then we won't get the TLE message, right? So I have to find the count of this 3 in this array, right? So what I would do is I'll perform binary search on this array and I'll search for 3, right? Now we have 2 3s over here. By performing binary search, I can get the position of either this 3 or this 3, right? So what I would do is, let's say I got the position of this 3. Then I would iterate on the left side of this 3 and on the right side of this 3, and I'll try to count how many 3s do I have. So this way I'll be able to count the frequency of 3 in this array, right? But the issue with this approach is that the binary search works in log n time complexity. But if, let's say, all the elements in this array contains only 3, right? In this case, firstly, I would get the position of any of these 3s. So let's say I got the position of this 3. Then I'll traverse on the left hand side till the very beginning of this array, and I'll travel on the right hand side till the end of this array. And in this case, my time complexity would become big O of n, right? Because I'm traversing the whole array. So this would definitely give us a TLE. So we need another approach to solve this problem. Now this is the code for binary search. We have to modify this a bit to get the first and the last location of this X in this array, right? So the initial value of low is 0, and the initial value of high is n minus 1. The size of this array is 7. 7 minus 1 equals to 6. So high would point at this position, right? Now I'll calculate this mid. Low plus high divided by 2. Low is 0. High is 6. 0 plus 6 divided by 2 would give me 3. So now my mid would point to this location, right? This location. So in this case, I would have simply stored this location in answer, and I would have simply gone out of this particular loop, right? And I have simply printed this answer. So this time this location is also 3, so answer would store 3 and it would simply print 3, right? Now this location of 3 is neither the first nor the last location, hence we still have to search in this array, right? So I'll remove this break from here, and I still have to search for 3 in this array. And if, let's say, I want to find the first index of 3, then I'll search on the left hand side of this 3, right? I'll search on the left hand side of this particular element, right? So now this is my range. Low would still be at 0. Low is still at 0. High is at 2, right? 1 less than the mid. So if mid, ARR of mid, if the element is equal to X, then answer would store the value of this mid, and my high would now store mid minus 1, right? Now my high would point to the left element of this mid, right? So now this is my range. Again, 0 plus 2 is 2. 2 divided by 2 is 1. So now my mid would point to this location. This is my mid. This is my low. This is my high. Right. So now I'm pointing to this location. This is the element. This is the X. These two are not equal. So I'll move on to this if condition. If ARR of mid is less than X, is this element smaller than this 3? The answer is yes. 2 is smaller than this 3. Hence, we'll simply perform this operation. Low equals to mid plus 1. So low is at 0, mid is at 1. So now mid plus 1 would be at 2. So now low would become 2, right? So now low would become 2 and high was already 2 in this case, right? Again, I'll go back. I'll calculate this mid. Low plus high divided by 2. So low and high both are at 2. So this time 2 plus 2 divided by 2. 2 plus 2 is 4. 4 divided by 2 is 2. So this time my mid is also 2, right? So my mid is also 2. So now I'm pointing to this location, right? So this element is 3. So this if condition would work. Mid would be stored in answer. Mid over here is 2. So now my answer would store 2. answer would store 2, and high would be mid minus 1, right? So now my high would point to this element 1, right? Or my high would be 1 in this case, right? My high was 1, my low is still 2. Low is still 2. I'll go back, I'll check this condition, this while condition, while low is less than or equals to high or not. Low is 2, high is 1. So is 2 less than equals to 1? The answer is no. So this is false. So I'll simply go out of this loop and I'll simply return this answer, right? Answer was storing 2, and as you can see that this 2 is the first location of this 3. So now my answer would return 2, right? Which is the first location of my x, right? Similarly, if I want to find the last index of this 3, then in the first case, I searched in the left hand side. So for that, I moved the high index to mid minus 1. I moved the high index to mid minus 1. But if I want to find the last index of this 3, then this time, instead of searching on the left hand side, I'll search on the right hand side, right? So this time high will stay as it is, and this time low will move to this location, right? 1 plus mid, right? This time low will become 1 plus mid. So this time, instead of this break, low will become 1 plus mid or mid plus 1, right? So using this low and mid, we can easily find the first and the last location of 3 in this array, right? So the first and the last location of 3 in this array is 2 and 4. So if I find, or if I simply find the difference of these two indexes, this 2 and 4. So 4 minus 2 would give me 2, right? And if I add simply plus 1 to this, then this would give me 3, which is the frequency of x, or the frequency of 3 in this array, right? Simply add plus 1 to the difference, right? So if let's say I wanted to find the frequency of 4 in this case, so the lowest or the first occurrence of this 4 in this array is 5, and the last occurrence of 4 in this array is also 5. So the first occurrence, so the last occurrence minus the first occurrence would give me 0. And if I add plus 1 to this, then now this 1 is the frequency of 4 in this array. We can verify that we only have 1 4 in this array, right? So this answer would store the first and the last index, depending upon whether we are writing high equals to mid minus 1 or low equals to mid plus 1 over here, right? This is for the first index, and this low equals to mid plus 1 is for the last index, right? So now let's move on to the code. So firstly, I'll input n and x, where n is the size of the array and x is the element whose frequency we have to find. Then I'll create a vector ARR of size n to store all the array elements. Then I'll simply store all the array elements inside this vector ARR. I'll create a variable ans to store the answer, a variable l to store the last index of this array or this x inside this array, and a variable f to store the last index of this variable x inside this array. If both l and f are -1, that is if both the last index is -1 and the first index is -1, that is if it is not present inside this array, then my answer would be 0. That is the frequency of that element is 0. It is not present inside this array. Otherwise, my answer would be l minus f plus 1, the last index minus first index plus 1, right? And at the end, I'll simply print this answer. These functions last and first are very similar to each other. And as we have discussed, in this first function, high would be mid -1 if ARR of mid is equals to x. And in the last function, this low would be mid plus 1, right? If ARR of mid is equals to x, right? So that completes the whole code. Let's run this code. So if I run this code, so we have to find the frequency of 3 in this array. So 3 is present 2 times, hence the frequency of 3 is 2. Similarly, the frequency of 4 in this array would be 1, right? 4 is present 1 time. And the frequency of 7, which is not inside this array, it would be 0, right? So here we can see that our answer is 0. So that is it for this video. Like if you understood the concept. In case of any doubts or feedback, do leave them in the comment section below. Subscribe to our channel and press the bell icon to get notified about our upcoming uploads. You can also join our Telegram group. The link is in the description, and I'll see you in the next one.